Many forms of data ultimately rely on numbers, and the process that makes this possible is called numeric encoding. Numeric encoding is the representation of information using numbers so that it can be stored, processed, and analyzed by computational systems. At the lowest level, computers work only with numbers. More specifically, they work with binary digits, zeros and ones. Everything else is built on top of that foundation. When we encode data numerically, we are mapping values, measurements, or concepts into numeric form. Some data is naturally numeric. Counts, measurements, prices, and durations already exist as numbers. But even here, representation matters. Take the number 10. It can be represented as an integer, a floating point value, or a fixed point number. Each representation affects precision, range, and performance. Other types of data are not inherently numeric, but can still be encoded numerically. For example, categories can be mapped to numbers. A product type might be encoded as 1, 2, or 3. A status might be encoded as 0 for inactive and 1 for active. These numbers don't carry meaning on their own. Their meaning comes from the encoding rules. Numeric encoding is especially important in analysis and modeling. Statistical methods, algorithms, and machine learning models operate on numbers. To make non-numeric data usable, it must first be converted into numeric form. This conversion can be simple, like assigning an ID to each category, or it can be more complex, like scaling values, normalizing ranges, or creating multiple numeric features from a single concept. But numeric encoding comes with trade-offs. Some encodings preserve order and distance, others do not. Encoding categories as numbers might suggest relationships that don't actually exist. For example, encoding colors as 1, 2, and 3 doesn't mean that color 2 is between the others. Precision is another concern. Floating point representations can introduce rounding errors. Large numbers may lose accuracy. Small differences may disappear entirely. That's why choosing a numeric encoding is never just a technical detail. It affects how data behaves when you compute with it. It affects how models learn patterns. And it affects the conclusions you draw from analysis. At its core, numeric encoding is about making data computable. It's the bridge between real-world information and mathematical operations. Without numeric encoding, modern data processing, from simple averages to advanced machine learning, wouldn't be possible. So whenever you see numbers in a dataset, don't assume they are just values. Ask how they were encoded, what they represent, and what assumptions are hidden behind them. Because in data, numbers don't just measure reality, they represent it.